Hello and welcome to another marvelous Angular Air episode. My name is Alyssa Nichol and I am the host. And today with me as panelists, I have Mike, who's very easy to point at. Hello, Mike.
How's it going?
He just Brady Bunched me. That was amazing.
Yeah,
And
gotta do that.
I'm going to get this one right. Are you all ready? Justin. Oh, did you see that? Did you
Nice.
see that perfect point you
Yeah,
just
yeah.
did? Welcome, Justin. How are you doing today?
I'm doing great. I'm a little scared to point to the corner because I don't know if I'm gonna get right, but I think this way. Yes. All right.
First try. Excellent. And we are so excited to have our guest of the hour, Lara Newsom. Hello, Lara. How are you doing?
Hello.
Oh my God.
I practiced that.
That way.
Nice to meet you. Hold on,
Oh my
reach out and
Wait.
there we go.
You're amazing. Oh my gosh. How are you doing today?
I'm good. This video thing is new for me because we just do audio on the Angular Plus show. So
Is it weird? I personally I think it adds a bit of pizzazz to the because there are people who only listen to the audio, of course, but
yeah.
the
The video is so the problem with video is remembering that I'm going to be on camera.
Oh, right. Mhm. Yeah.
Like this morning, I was like, oh yeah, not that shirt. So I went for the
I saw we're
2020
repping
hardwired NG comp. Yeah.
repping. So I actually saw Lara at DevUp recently in St.
Yes.
Louis,
Yes.
and I wanted to go see her talk, and things blew up as they do at conferences, and I was needed at the booth, and so I was like, Lara, please, could you come and talk to our audience and to me about like your topic, which is reactive patterns in Angular. And so she was so gracious to agree to come on. And Lara's been a longtime friend and someone in the community that I've always respected and looked up to. So I am just so excited to have you on today. Thank you, Lara.
Yeah, I'm excited to be here. And I'm excited like this. I feel like the talk it's even more pertinent because, V17 is going to be out pretty soon. And, we're like signals are kind of landing, and then there's all these like new things coming. It's really exciting time in the world of Angular. So why not learn some new patterns?
I love it. Lars just said, quick comment. I jumped the gun using NG17 next 7 in our internal app. Absolutely in love with the new template syntax. At defer is so awesome. It's crazy. I know. I keep hearing. I talked with
my gosh,
Mark,
seriously.
and that's the thing that Mark recently was like, defer. It must be all about it. So I'm have you played with it? I have not played with defer yet.
I have not yet, but I have so the app that I work on at Cisco has some legacy components that are not optimal, and they're not.
When you say not optimal, what's this component doing?
Like they still have some Lodash lurking in there, like not some Lodash. They have a lot of Lodash lurking in there. They still use Moment to do things like format dates. So they're these kind of, and nobody really owns them. And so it's hard to prioritize refactoring them. And honestly, most of us didn't realize they were part of the app until we started looking at our bundles, and we're like, why is this coming in on this? It's not on the main bundle. At least we've got it lazy loaded, but it's coming in on one of the bundles that has to load when the page loads, but the user rarely goes there. And so defer is the perfect situation for that. So I'm really excited to get to play around with that and then actually get to use it, because I think it's going to be kind of a game changer. So the other option is to do that, dynamically load your component, and it's okay. I mean, like there's a way to do it. There's a couple ways to do it, and they're all like, it's like old school typing a lot of code. And for a software engineer, I don't like typing a lot of code. So I'd rather just defer it.
It'll be interesting on the flip side of it if like it solves the problem of the moment JS, like then does it hide it away from us and we forget to go fix it, right? Like that's another challenge. Like, make a ticket in the backlog to address it.
Exactly. And that's honestly what's been happening to us is we'll get it out of the bundle and then it just goes to the next one and you're like, ah. So it's hopefully it'll like, it's like I feel like in those cases it's a Band-Aid, but in general, I think it's just going to be really exciting. I think it just opens up a whole new way to think about how to write your applications and how to optimize your users' experience. So yeah, very exciting stuff.
So tell us, do you want me to share your slide deck? I know we're going to talk about the reactive patterns. I don't know at what point I can add her in.
Yeah. And I don't know if I go into like slideshow mode, is it doing it? Yay, it's doing it. So this is, of course, the slide I'd show at the beginning. I do work at Cisco on the customer experience team. We have a really large enterprise Angular application. When I joined, we would call it legacy, even though it was only a few years old. But it needed a lot of work. And so a lot of what I learned about reactivity in Angular is because of the work I've done on the application and just how to sort of incrementally make my life easier one component at a time. So yeah, definitely have a lot of experience there. I'm on I also host another Angular podcast. And so I love that I love all the different formats for podcasts. Like I love that yours is a video because it's really, really hard to talk about code on a podcast. What the user can't see is that I am typing. So yeah. And then, I'm an Angular GDE and NX champion. There's some other slides in here. And you can reach out to me in various formats. I kind of recently just decommissioned my Twitter account. I still technically own it, but it's because I'm afraid somebody will take it and be me. But
I didn't think about that.
Yeah, so I'm like, I want to get rid of it, but I also don't want to like loose it to the world. So, but if you're looking to reach out to me, LinkedIn is actually probably the best place to reach out to me, and I'm happy to communicate with people on there. So yeah, I wrote a talk called Reactive Patterns for Angular. That QR code will take you to the slide deck. And there is another slide at the end with the repository link and a tiny URL that will take you to this slide deck as well. But like when it comes to reactivity, we talk about it a lot. I think a lot of people aren't really sure what it means. There's a lot of different definitions out there. But bottom line is JavaScript has asynchronous events. We have to manage state as data keeps changing, and users expect the view to refresh accurately and quickly, right? So it's like our users are expecting more and more out of our applications. That full postback is no longer an acceptable solution anymore. Like we need to have these nice user experiences that make it seem like it's easy and no work is being done, right? So and you might be thinking to yourself, but aren't signals here to just make my whole app reactive? And I feel like when they kind of hit the scene, that was sort of the vibe, right? Like signals are here. Our apps are going to finally be reactive. And I'm like, no, like that is not what's going to happen. Like they're not going to make your code magically reactive. You're still going to have to do some work and understand reactivity. And so another reason we should care about reactivity is, of course, that with version 16, they introduced signals in developer preview, and they're just going to keep going. They're looking towards integrating signals more deeply with some of the built-in Angular libraries. I'm hoping they get to forms. Forms are traditionally kind of a nightmare. So it'll be really great to get some good signals integration with that. So yeah, here's some things. I'm going to kind of gloss over some of these slides. I'm not going to do that. I'm not doing the whole spiel because normally nobody's talking to me during this. So I also keep looking over here because that's where I can see myself on the monitor. So my camera is right here. So if I'm not making eye contact, that's why not. But if you can understand reactivity now, you can work to improve your code now, and then you can leverage all these new features as they get released. So it is really important to sort of build an understanding of what your application is doing and why reactivity matters. And then some of you might be in the audience saying, wait, what's a signal, right? Because I did not know what a signal was when they started talking about them, or I'd heard about them, but I wasn't really sure what it meant.
I thought it was like a brand new Angular thing. My friends were like, no, this has been around. I was like, I'm pretty sure the Angular team invented this.
Right,
concept.
exactly. Because we live in this I live in an Angular bubble. And so I don't really, I mean, sometimes I see what's happening outside of my bubble, but not all the time. So signals are really not a new idea. They've been around a very long time. And the best mental model I have for it is spreadsheet functions. So, if you make an Excel spreadsheet or a number spreadsheet and you change one cell, all the other cells automatically recalculate without refreshing the whole screen. So it just it knows which cells care and it updates just those cells. And so that model for me makes a lot of sense. And so that's the model I try to show. And this was not my example. I believe this was Ryan Carniato had this example in an article that he wrote. So I don't take credit for this, but this was the mental model that helped me the most. So signals in JavaScript are a new reactive primitive. They execute synchronously, and they hopefully will allow fine-grained reactivity. So that's sort of the point of them. And then I don't remember if I don't think I get into fine-grained reactivity, but I do want to get into that a little bit because that's a really important part of it. Currently in Angular, change detection executes from the top down. So if change detection runs in your app, the app uses Zone.js to say, I know something happened. I better go check everywhere to see what changed. And we have some strategies like on push change detection where we can say, when change detection runs, don't run this one unless we tell you to. So we have some strategies to kind of mitigate that cascade of change detection that happens, but it's not perfect. Now, fine-grained reactivity, where we can hopefully get is to say, hey, I'm a signal. I know which parts of the DOM care about me. I just changed, go update those, just those. And so that's where we're hoping to get is sort of instead of running that whole change detection tree, instead of relying on Zone.js, we can actually just update the pieces of the DOM that need to be updated so that our users are getting the information they need without having to wait for the whole application to repaint.
Do you have those nibbly jibbly feelings that some developers have towards Zone.js, or is she your one true love that you are?
I'm like, somebody asked me once, what would you do if Angular went away? And I'm like, well, I write code in something else. So, it's like, and I feel that way about Zone.js. It's like, I'm excited for the idea of a different strategy because there's definitely some, like when you run into a change detection bug, it's like a spidey sense almost. Every new developer's like, how did you know what that is? And I'm like, well, it's because a new value came into your observable. And then when you clicked on the page, it updated. I'm like, that's change detection, but it takes a while to kind of get that intuition of this feels like a change detection bug. And so it would be nice to have a more intuitive way to do some of that stuff, especially when people start to implement on push. I feel like the biggest mistake I see is that they'll put it at the parent component and not realize they didn't refactor any of the child components. And once you've disconnected the parent component from the change detection tree, change detection is only going to run if you tell it to on everything down the tree. And so that can be really confusing. That's a really difficult bug to, you'll recognize, hey, it's a change detection bug. Why is it happening? And then you have to start looking up the tree to say, oh, somebody changed this on push, a few commits ago. So yeah, I guess I'm always just happy to get new tools. So yeah, no love or hate for Zone.js. I understand why they did it that way in the beginning, and I'm excited to see what will happen later.
Me too. I'm very excited. I'm also. What were you saying?
No, you're good.
It's like that settling into the fact that like we work in the web world, which is ever changing.
Right.
And as soon as you're adopting, like, I'm ready, I'm accepting change and I'm ready for it, and I'm going to embrace it, then kind of everything falls in line, right?
Yeah, exactly. And it's just really getting over that. I mean, honestly, even when standalone components were released, I had that like, oh God, what is this thing I have to learn now? Like it seemed like this big concept that I really was going to have to take a long time to get my head around. And then I started using it and I was like, oh, well, that's easy. There's a few like little gotchas like with providers and stuff. If you've got to like providing the router, you do that differently, stuff like that. But it's really not a big deal. And I feel like signals is kind of that thing too. There's some rules you need to learn, and there will be some changes, but I think they're going to be rolling out incrementally. So I don't feel like it's going to be a waterfall, like just getting a bucket of change dumped on your head. You'll get like a few drips of change on your head, and then maybe a few streams here and there, but yeah. So to carry on though, we need to be, the one gotcha with signals that I have found is that we have to be very careful not to do asynchronous things inside of our synchronous code. And so there's some patterns that we'll need to follow with signals to make sure that we're not trying to subscribe to an observable inside a computed signal. That's not going to work. So there's gotchas like that people are going to have to be aware of. So to dissect a signal, there's really like three parts to it. There's a getter, there's a setter, and then it does consumer tracking. And so it really, the beauty of it is that, and I'll show this later in one of the patterns, that we no longer have to write so they kind of act like subjects, honestly, where they can store a value and they can multicast it out, essentially. But a subject doesn't know it kind of knows what's listening to it, but not in the same way that a signal knows. And when we're using subjects, we have to be very careful not to expose that subject publicly. Because if you expose the subject publicly, then anywhere in your code, somebody can accidentally shut down that stream, and then it's no longer available in the application. So with the signal, though, the getter and the setter are built into it. So it eliminates a lot of that extra code that you end up writing with a behavior subject. And the consumer tracking is what allows for the fine-grained reactivity, because it knows what's going on. And Marcus is here. Hi, Marcus. It's because I'm watching the monitor over here. So regular reactivity relies on the framework's change detection strategy to determine which DOM nodes need to be updated. And that's what we were talking about, that top-down change detection. It goes through dirty checking. There's articles you can read about how Angular change detection works. I'm not going to go into that in this talk. But it basically works like this. Something happened. Oh, I better go check every single DOM node just in case there's changes. And so it starts to, in a very small app, you're not going to notice that, but in a really large application, you start to notice that can be slow. Fine-grained reactivity is going to allow us to update specific nodes of that fine-grained reactivity. So it says this specific thing happens, and it says, oh, that only affects these things. Let's go update those. So that's where we're trying to move to. And this is how solid.js works out of the box. Vue is really close, but it still relies on the virtual DOM. So if you, there's a lot of articles out there by Ryan Carniato that I really recommend people read if you're having trouble kind of getting your head around the idea of fine-grained reactivity and signals. So in this talk, I'm going to give examples of how to use signals in addition to observable streams, because people, when the signals came out, they're like, oh, is RxJS going away? And I'm like, no, friend, it can't. Like, there's still asynchronous events that are happening, and we still have to deal with those. So yeah, it's going to be kind of a hybrid situation. So all those RxJS, hard-won RxJS skills that you may have developed over the years, you're still going to need them. You're still going to need to understand that some things, like the HTTP client, for example, that's asynchronous. I don't know how they would ever make that not, because you send out a request and some amount of time has to pass, and then the response comes back. And so there's always going to be time involved in that.
I say we push all the database servers and the web server directly to the browser, and this way it can just be synchronous and we won't have to worry about that at all.
Right.
Mike Brocky has solved it. Oh my God.
So our typical app load just delivers everything. So there's just a long loading screen. And then once it settles, we're good, right?
Yeah, after an hour or two, you'll be fine to use the app. It's
you
cool.
just never close your browser.
And then you never close it.
Right, exactly.
And you can't share information, so sorry.
No, it's probably not going to stay up to date, but that's fine. It'll be up to date with whatever you change. So today we're going to talk about what is reactivity, what tools we have, and what changes can you make today to your application.
I'm so excited. I'm so excited, Laura.
I like this talk because it really hits home to me. So what is reactivity? It really depends who you ask, right? You're going to get a lot of answers out there. I tend to lean towards the handling real-time view updates to asynchronous changes. But yeah, you're going to get a lot of.
Oh, is that all? That's what you.
That's
that
simply,
definition. I got you. Cool.
I don't know. I got to pick one, right? But honestly, sometimes it's the buzzword to make me feel bad about my code, right? This isn't very active. Like, okay, I know. Stop it. So really, with reactivity, you have 3 ingredients. You've got producers, you've got consumers, and you've got side effects. So producers are events or elements that are capable of being observed. So we have a lot of producer examples in Angular: user events, event emitters, all these here. And we'll be taking that asterisk off here pretty soon. So that's really exciting. And then we've got our consumers. Consumers observe producers and use the results. So components, view templates, something like the component store or NGRX reducers. These are things that really just take in the results and just use them, right? Then we have side effects. And this is where it gets a little confusing for people, but they're basically consumers that will intercept the events and then do something and then emit another event. So really similar programming concepts are like middleware. So if you're coming from the .NET world, .NET Core uses middleware, particularly for something like authentication, right? A request comes in, it runs through this thing, and the result comes out, and then you carry on. And so that's essentially what these side effects do. Monads, higher order functions. In Angular, we have a lot of side effects examples. We can make data services. NGRX effects are literally for side effects. That's why it says effects in there. Interceptors, the RxJS pipes, the operators. And so then in signals, we have computed and effects that we can use to sort of do work upon the signals that are coming in. So let's put these ingredients together. So we've got our producers. They're just like, hey, something happened. Everybody listen. And the side effects and the consumers were sitting around. They're like, I'm just waiting. I have this one thing I care about, and I'm just waiting to hear what happens. And so for SpongeBob, he's waiting for order in. That's all he cares about. And he knows when order comes in, Krabby Patties go out. So he's a side effect. And then we've got Squidward out in the lobby, and all he cares about is that it's Krabby Patty time, right? So he's going to consume those results without side effects, we hope, right? So maybe heartburn. But we get into trouble when we mix up these responsibilities. And so we all have components that work kind of like this, where it's like lines of code this way, that way, and you're never sure. I mean, I've opened components like this, 3,000, 2,000, 1,000 lines of code, and I have to figure out what happens when somebody clicks this button. And then you start down the chain of all of the class methods that are just mutating random arrays and toggling Boolean values.
Oh my goodness, it sounds like so much fun.
Yeah, it works, right? Like they work, but no one wants to touch them. And in fact, I have a component just like this whose code I show a lot, or, a similar version of the code, because it works, and I'm afraid to touch it because they'll say, oh, can you fix this little bit of it? And I'm like, yes. Caveat is I'll probably break the code. Like I'll break something else for sure. So
6 months.
Yeah, exactly. Well, I was trying to decide what the contract, contractors are always like 2 weeks. And I'm like, what's the contractor, like the software engineer version of 2 weeks? I'm like 2 sprints. I'll get that to you in 2 sprints. So to help with consistent responsibilities, we can talk about imperative versus declarative. And so imperative programming is very typical of object-oriented languages. It's a very process-based approach, and state is managed step by step. And this is how a lot of us are taught to code, because this is how our brains sort of work. You think, I need to go make a sandwich. First, I need to go into the kitchen. Then I need to open the refrigerator. Then I need to get the meat out, and you go through all the steps of making the sandwich, and then you eat the sandwich. So imperatively declared code is trying to strip time away from the equation. It's saying that I have to do things step by step because there's no way I can go and get the bread and the meat at the same time. That's a weird example, but here's an example in code of imperatively declared code. So this is a class method that's dictating what to return. So it's returning the results of another method, but there's nothing to prevent us from doing stuff like this. And this is where Angular starts to go sideways, when you've got a bunch of class properties and you're mutating them inside of class methods. So I know we've all got some sort of random method in our code that does something like update params, where it's like, oh, when something changes, I want you to go update the query parameters, and you're not sure what it's doing because it doesn't take any properties, but it does some work. We're not sure what. I'll have to go see. And then we get all of these other class properties that are getting mutated. And this is always in an attempt to manage state locally. So mutation, right? So common imperative coding issues are excessive class properties, tightly coupled code, random side effects from void methods. These are all things we've all seen in Angular code. And whenever I show code that looks like this, somebody says, I thought that was my code. And it's because we all do the same things. So side effects that can result in, so when you mutate objects in these buried methods, you can end up with bugs that are really frustrating to decode because you're having to tunnel deep, deep, deep to see why this object property isn't the value that you thought it should be. Or why change detection didn't run, or why, there's a lot of things that can come up. So when we talk about mutable versus immutable, mutable state changes, in order to verify that any change happened, you have to do deep equality checking. And it's really common in imperative code, and it's sneaky. So immutable code, state cannot change, referential checking, all of those things. And this is, so immutable state, a lot of like the Redux pattern, we're relying on immutable state inside the Redux store to tell us when a new value came in. So we don't have to check the entire state object to say, oh, did anything change? We can just say, well, something changed because I got a new object reference. So imperative code tells the machine what to do step by step, and this makes asynchronous events very difficult to manage. So when you force asynchronous code to behave synchronously, you get increased wait times, race conditions, incorrect state, right? So everyone loves waiting, right? That's everyone's favorite thing to do on the internet. So if you async await everything, it will work. You can force your code to execute synchronously, but you're also forcing your users to wait. You can introduce race conditions. This is very easy to do with observable streams. So if you fire off multiple asynchronous requests and you're running using the results synchronously, you have no idea if they've returned in the correct order. So if you fire off 2 requests at the same time, there's nothing to keep that kayaker from going and stopping on shore to go to the bathroom or from capsizing, right? There's nothing to prevent the order of return there. So they're also really particularly difficult to diagnose because you usually don't see them until you're in production, because when you're running locally, things execute quicker. And it's almost always when you're dealing with somebody who's on some edge location and they're making these requests that are a little bit slower that we start to see these race conditions turning up. So they're hard to replicate. And then you can end up with mismatched data. So this is my joke. I live in Iowa. If you live in Iowa, Idaho, or Ohio, you get this joke because everyone thinks it's literally the same state.
Oh my God, yes.
So, and this is funny, but it can really cost companies significantly. So if you imagine that you've got a Black Friday sale where you've got 10 PlayStations and 10 smart TVs, and somebody clicks on the smart TV and they click on it and we want to get how many products are left. So you send off a request to do that. And then they change their mind and they click on the PlayStation, but you haven't managed the order of return. So maybe you're doing a nested subscription and you end up where that request to get the PlayStation totals never comes back, or it comes back really fast. And then the total from the TV request comes back and it says, oh, we have 10 PlayStations, when really you have none. Now your company has a problem they have to deal with. So that is very common. So the alternative is declarative programming, or one alternative, right? So this is typical of functional programming languages. It's a results-oriented approach, and it's stateless and execution order agnostic, which is what we need for asynchronous applications. So declarative code is considering time, and so that's why it works well with asynchronous execution. So it's just considering it as sort of this other dimension. So we have a lot of declarative libraries out there in the world, and some of these you might notice are very old. This is not a new idea. I personally think that imperatively programmed languages took off because of how our brains work and how it is easier to teach how to do that. So declarative code example, in this case, we're still getting the results of the getCats method, but instead of returning it, we're actually just declaring a property equal to it. So that's the difference here. And there's no room for side effects in here. I can't add those lines above the return method. or the return in the method. But we can still manipulate the results, and we can do that. The only way to then change the values coming through the stream is by pushing a new value through it. So if we set up the changes to happen inside the stream is managing those changes, and we can make the changes, we can get new values out by pushing new values in. And we can similarly declare signals as well. So, which is a little easier. And then this is a way that we could create a view model where if anytime the cat signal is changing, we want to recompute that view model. So if the computed rec notices that the cat signal has a new value, it's going to rerun its callback function. So we can control the asynchronous code by composing it into streams. So there's a lot of different stream composition libraries out. I understood RxJS fairly well because of Link, because it's the same idea of like value in, value out. Like it's just, you're just kind of making a little factory, right? And Link and RxJS are not the same thing, but it's similar.
That brings back memories. It's been a minute since I worked on Link, but now all of a sudden,
oh yeah,
name I haven't heard in quite some time.
I know, right? And it's like, it's one of those things where you're like, once I started understanding, I was like, oh my gosh, this is like kind of magical. I really love this, because you set up these little machines, right? So here's our iced coffee machine. If I want an iced coffee to come out, I have to push a cup in, right? So I have to set a new value into the stream. And I've got one operation that adds ice to the cup and one operation that adds espresso to the cup. So we're not getting a cup in, a cup out. We're getting a cup in and an iced coffee out. So we're doing work upon that, the values in the stream in our stream composition. So the benefit of this is it creates units of reusable code. RxJS is lazily evaluated. So that means you can set up a whole bunch of them and they're not going to be evaluated until you actually subscribe to them. And so then you also, the benefit is also that you can't get a new output value until you put in a new input value. So, so it's also, since you're doing work on each individual value, you know that each value has had the work done upon it. Whereas if you're doing like a nested subscription, you may not get a one-to-one, like once anything is out of the stream no longer controls it. So it's no longer in the machine. It's just kind of like you throw a cup out and maybe somebody's going to put ice in it. It's like, please put ice in my cup. No, sorry, I put Coke in there. So, and then it also gives us the ability to combine asynchronous requests. So we do that a lot in Angular, where if we have like a selected ID that's changing, and when we get a new ID, we want to go get details for that product using a asynchronous request. So we can not nest those together, but compose those together. All right, so imperative code declared inside of declarative code is going to reintroduce some of the same problems we're trying to avoid. So there are some gotchas there. This is a very common declarative, as I like to call it, where you've scoped a property outside of your stream, and then you set it inside of your stream. Maybe nothing bad will happen because maybe your stream is the only one that knows about this property, but there is nothing to stop your coworkers from coming along and just wiping that property out in some method. Mm-hmm. So we don't want to, again, we want to just keep everything inside of our stream. So
I want a lint rule that blocks that, or lets us know that happened. Wouldn't that be great?
Yeah, it would be so great, because it's really easy to do, because it is, you're kind of just turning your head upside down to think about these. And so in this case, we still can get breeds out, but we want to wrap them in this view model, which is that VM $ observable. So the only way to get a new calculation of the breeds property out is to get a new value for the cats coming in. I said that, I think. Next declarative, nested subscriptions, right? So this is where we were talking about race conditions. And this is the example where I talked about the PlayStations and the TVs, right? So if in this example, let's say, you select a cat and then you go in to then get the breed for that cat, and you have to subscribe to it for some reason, because for some reason it wasn't on the object. There's nothing to prevent the user from just sort of spamming, like clicking all the buttons, and then the requests are just kind of coming back whenever they come back. So you might get some very confusing results in the view for your user. This right here, exactly this. So the more declarative way to do this is to compose the requests inside the stream. And this means the stream manages the inner requests. So the benefit of it's doing the exact same thing. We still get a value in for the cat. We're still going to then use that value inside and use that to fetch the breed from a request. But the difference here is now the observable stream is managing that inner subscription. So it knows, like with switch map, for example, if I select a cat, now I have access to that cat property. Then I can use that cat property in a new observable and do whatever I want with it. And so in this case, I can then get the selected cat and its breed. I'm going to map that and return that. But if I select a new cat, it actually cancels that inner observable. So that's just gone. And then only the new one comes in, and it has to be matched up because the only result you're going to get out is the get breed method call that was made with that cat that was just last selected. And that's just how switch map works. That's a flattening mapping operator. There's 4 of them that get used the most, and there's information out there on that. Somebody did an entire talk about it. It's me. All right. So problems with declarative programming, it's a higher learning curve. It's not always easy to read, and it is not how we're taught to think about code. Or most of us. Some of us are. Some of us are just naturally good at it, right? But it's really just kind of like turning your head upside down. You just kind of have to think of it differently. Now, signals make that a little easier because it does feel more imperative, because it's synchronous, but you still have to think about how the data gets into the pipeline. But this guy just wants to use signals because he doesn't really care about, all he wants is the new stuff, right? So we can set up our code to be ready to use signals later. Or you can use them now. We aren't using them at Cisco because we aren't yet, well, V17 hasn't been released and we're not there yet, but they are fairly stable. So we're going to use setters on our inputs instead of ng on changes. So this is something I see a lot, code like this, where we have input properties and ng on changes is going to run anytime one of those input property changes, but it doesn't know which one changed. So we have to include all this logic to figure out what changed. So it's going to run over and over and over again. And there's all that logic that has to be in there. And it's only going to know that something changed, not what changed. So we can be a little more precise. We can actually use the set keyword to turn this into a setter. So the value coming in is the changing value. And then I'm going to use that on my product service to set my selected product, right? And so the benefit of using a setter is it runs only when that input changes. I don't have to use that logic, and I don't need to implement ng on changes. Because ng on changes, there's some weird like checking you have to do to make sure you're drilling into the right property. And then this pattern can be very easily adapted to signals, which is great. So now it's a signal. Like that's the change. Like now it's a signal. So we're using the setter. I'm pointing at my screen helpfully, y'all. Okay. You can't see. There, right here. Setter. Because signals have built-in getters and setters. And check me out, I'm a signal. All right, pattern number 2. We're going to cut out the middleman when we're dispatching user events and actions. So we're going to have a little chat about component output properties. So they're really great for passing data from child to parent, but when you start to see a lot of problems when you're saying, I want to pass, child to parent. I want to pass something from this child over to this cousin, right? I want to go up the tree several levels and then back down the tree. This tightly emits the emitting component to the tree. So if you're emitting up a value everywhere up that chain, it's got to know what shape that value is, and it's got to retain that data integrity so that as it comes back down the tree, it's exactly the same, right? And at any point, somebody could mutate it on that chain, like plain telephone. And so this is kind of how that code looks. So I'm going to select the product, I'm going to emit it, and it's going to start going up through the tree. So child 1, click, it's going to emit it to the parent, emit it to app root, down to parent 2, down to child 2. And it's like, hey, thanks for the update, right? So that's 6 or 5 components involved just to get data from one to the other. But what we really need is a stateful service that can be accessed from anywhere in the application. So we've got our stateful service. Our child 1 can communicate with child 2 through a stateful service, right? So child 1 says, something happened. Stateful service says, I got you. And then it passes it to child 2, right? So it acts as that middleman, but actually it can update all of the components at the same time with the same data. So there's no chance that somebody messed up the data along that chain. So built-in stateful options, service with a subject, service with a signal, and router module. So I like to use router module to do stuff like sharing product links, So we've got our professional doggo glasses here. I want to share this with my boss, Spivey, because dude loves dogs and dogs in glasses. So I'm going to get this to him immediately, right? So I'm going to leverage the Angular router. So how this is going to work is I'm going to select a product. I'm not going to do anything except update the route with the query parameter. The router is then the stateful store is listening to the router for changes for the query parameters. And when it gets a new value off the route, it's going to emit it to the components that care, right? So just those components are getting updated with exactly the same value at exactly the same time. So what you might have noticed is the detail view actually set the route, but it's still getting updates the same way. We want to retain that. That flow of data. So we have to be very careful to maintain a single state of set of flow to state too, though, because this happens a lot where people are like, oh, I select a product, I gotta set it on the selected product service, and then I'm gonna router.navigate. Well, y'all don't need to do that anymore, right? Just router.navigate, trust that the stateful store already knows how to get the parameters and use them directly that way. So we're gonna combine the first pattern with the second. So a user is gonna select a category from the header. So this header value is going to go into the route param. So it's going to become a path segment. So when they click on a category, it adds a path segment to the route. Since it's a path segment, it means it has to be consumed by a component on the activated route here. So in that case, as of v16, we can actually bind route parameters to our input properties, which is really awesome. So we're going to use the input setter pattern that we talked about in the first step. And you might be thinking, where did you do that? And I'm like, literally right here in the setter, right? Because it's easy to do now. So this is the module declaration for this. There's also a standalone component declaration. It's slightly different, but it's like I can't remember what it is, but you set it in the main.ts. And now we're going to step through how this works in our component, right? So we're going to use the setter. It's bound to the path changes. We're going to set it in the product service, right? We're going to use that set selected categories method, this is in the product service. So we're using a behavior subject in this service. So we have our setter, which is our set selected category, because we don't want to make our subject public. So it calls next on the behavior subject. It's like, okay, I got that. And then inside of the product service, we want to expose the observable property of the subject. We don't want to make that public because then at any point somebody could shut that down. Okay, but let's do it again with signals, because that's still a lot of typing, right? So signals look like this. I'm going to set it. I'm going to use my setter. I'm setting it here. I'm invoking the setter on the signal, and this is all we have in our service. So it's kind of a lot better. The reason that this would be like this works for this is because we're just setting a string value, right? It's a very simple value that we're setting. And it's easy to, we don't need to retain any values. It's just like, read the value. Just what's the selected category? I need to know what it is right now.
I have a question. So for the observable, you're exposing a method to hide the behavior subject, just so people couldn't next on that. But with the signal, it's kind of like doing the same thing because you're exposing a signal which anyone can then set the value to. Do you recommend setting up a function to be able to manage passing values into that signal?
I don't think it's necessary, because I don't think there's anything that you can just you can't just shut down a signal. It either exists or it doesn't, is my understanding, but maybe I'm wrong. But I don't think that you can shut it down. I think it's sort of like a Java property where it exists or it doesn't. I'm just going to throw out all the old school. I've been hurt before, everybody.
I think you're right that it is long living and you don't have to worry about that going through.
Yeah.
But yeah, it's the same idea of being able to next through it, to be able to manage and potentially provide some validation there around that.
Yeah. So yeah, but it's just so much less code that you need to write. And I feel like it's just a little more straightforward, especially for somebody coming out of something like Java or even C#. C# has also the concept of getters and setters. You just usually don't write them. So, which was the painful thing I learned.
Less typing.
Less typing. So the next pattern we're going to talk about is composing data before it gets to the consumer. So this is where we're making our cool little coffee machine, right? So why compose the data? And that is because components then have less responsibility. If you have a 3,000 line component and you've ever tried to write unit tests that test 100% of that code, you're in for pain, because the amount of state you have to pass in every single time is so huge. It gets to be, I've written 10,000 line test files to adequately test a 3,000 line component. It's brutal. And honestly, usually I just don't test them because it's easier to rewrite them and rewrite the expectations. Write an end-to-end test and then rewrite the whole component. Throw that in the garbage. It's I didn't just tell you to throw away all your code, but I did just tell you to throw away all your code.
That's what. Right. Yeah, that's what we heard.
If you have a viable replacement for it, right?
Right, exactly. Lift.
Oh my God, Justin, that's what my husband always says. He's like, "Why did you throw out all our dishes?" I was like, "Because we wanted new dishes," and he's like, "But we don't have them yet." And I'm like, "Oh." Right. So that's good. Right. Write the new code.
Right.
Then
get the dishes. Get the new dishes first. I would do the same thing. I'd be like, wait, now we have no dishes.
Right.
I'm like, I'm still waiting for them to come, right?
Throw away your dishes.
I'm with you. I'm with you. This is a good pattern to learn too. Okay.
Exactly. Lift and shift is what we call that. So, and so it's easier to test services than it is to test components. If you're testing components, so we test components from the public API. So we want you to, in order to invoke a method, we want you to actually click the element that invokes that method. That can be a pain in the butt sometimes. And so it's really nice in services because then you can just invoke the method and you are legitimately testing it the correct way. So it's easier to test. And then all of the consumers are going to get the exact same values. I don't know how many of you have code where it's like almost identical code in every single component because they're just like, I need to like make sure this thing matches up. But every single one of them does it just like a little bit different. And so you're like, well, which one is right? I'm not sure because they're all slightly different. So if you compose your data in streams, you're like, no, this is the one source. This is how we do this. This is the way. This is the way. And then you have to remember that all consumers want to do is consume. They don't really care where they're getting their data from. They just want to eat it. Like my cat. All right. So we're going to combine our patterns. Input setters, emit events where they happen, and compose data before it gets to the consumers. So we're going to see this state flow. We've got users clicking on a category. So click, it's going to set the category. It's going to set it in the router, which is then going to go to the product view, right? Because that's a path parameter. So we need to consume that in the component through the input property because it's not available to the store. And then the input on the component is going to set the value in the state store. That's then going to let the component know what that value is. I know that's a little bit backwards, but if it wasn't the same component, it would look, you could be updating like this, right? So everybody's getting the same value at once. So let's see how we compose and consume that data. So inside the product service, so this is the product service where we're setting our behavior subject. We have a stream. This is our composed data, filtered products. Now we're using the selected category as the outer observable because that is the one most likely to change in value. So if you use the products, you're never going to get new values in. So it's easier to that's where the flip is for me. It's like, oh, the more frequently changing is the one I want to use. So we're using this products, that is a observable of all the products that we've fetched and stored on initialization of this service. We're using switch map so we can get access to not only the selected category, but then the products coming out of that inner observable stream at the same time so that then we can filter the products by category. So that's all that's happening here. And then in the component, we're going to declare an observable property, and we're going to set it equal to the observable from the product service, that observable stream that we just set up in the service. All right. And then in our template, we're going to use the async pipe. Now we're using the async pipe because that will automatically handle subscribing and unsubscribing for us. And it also then will set up your component. If you did want to use on push change detection, it will mark your component for check anytime a new value comes in. All right, but let's see how this looks with signals. So this is inside the service. So we've got a computed signal in here, the filtered products, and we're going to use the selected category signal. So anytime selected category updates, it's going to run and refilter those products that we're also using inside this computed signal. So it's all signals inside of there. I'm not using observables inside of this. And then inside of our component, I'm going to then consume it. I'm going to declare a value. And then in the template, we don't need to use the async pipe. We can just directly invoke the getter on the signal. So that's all this looks like. And I do have all these code examples. So if this is confusing, we'll see those. So we're going to practice this one more time with the selected product flow. So in this case, the users can select products from the side menu, but they can also select them from the home page. So we're going to use these as a query parameter. Because we want to update the header and the product detail at the same time. And so the query parameters are available globally inside the route. So we're going to walk through the flow for selected product. So user selects a product, click, change the route. We add a query parameter. Since it's a query parameter and it is globally available, while we could access it on an input property, we don't know if that's the route that we're going to be on. So we want to just pass it directly to the state. The state store can consume the query parameters directly. So that's what we're going to do. And then the state store is going to update the components that care, and we get to see that Pooch Pants are on sale. Now we can do the same flow from the feature product side. It's going to be the same flow regardless of where that route change is initiated. Meanwhile, in the code, I said this already, but I also want to just reiterate that since it is globally available, setting it in the service as the single source of truth will prevent you from having multiple input properties on random components also updating things. So this is how we add a query parameter. We can use the query parameter input property on the router link directive. And then inside the service, this is the product service, we're going to then inject the activated route. And you can see here I'm using toSignal. So that's going to take in an observable and turn it into a signal for us. So it's sort of, this is using the RxJS interop package. It's magic. It's not magic, it's code, but it's magic to me because I haven't looked through how it works. But the cool thing about this is anytime it gets a new value, it's going to then tell the signal will say, I have a new value, and everybody will update as expected. And then inside our service, we've got our selected product, which is a computed signal. And we're going to use the products that we've previously gathered. I think up here, you can see we've invoked this here. And then we're going to get the selected product ID. We're going to find it. If it is exactly equal to the ID, then we're going to return it. If it's not there, it'll return undefined, which is kind of what we would want anyway. And then inside our consuming components, we just need to declare a local property, set it equal to the selected product signal coming from the stateful service. And then once again, in the template, we'll just invoke the getter directly on the signal. And then both components are going to get the same value at the same time. So we're going to know that Pooch Pants are on sale. So that's really exciting, right? So we've got the header and the detail get the same value at the same time, and OMG. So together, all three patterns, we've defined a holistic data flow that can be followed throughout the application, right? So if you keep following this, if you set up a data flow that goes, you understand the way your data flows through the app, you won't get into that like traffic situation where you're trying to figure out what updated what, when, and where, and how. So we've orchestrated a clear flow of data through the application. We've created and maintained a single source of truth, and we're composing data so that all consumers are getting the same data at the same time in the same way, right? And then you'll find that even without signals, if you follow some of these patterns, you can really improve the quality of your code. I've gone through 3,000 line components and really just figured out, okay, what is this thing actually trying to do? Because usually what you find in those 3,000 line components is there's a lot of double checking, triple checking to make sure the state is in the state that you think it should be in. And there's a lot of extra properties involved with that. So if you set up a flow where you're like, if I click on this, it comes down this way. It always follows the same flow. And then you know that you're always getting the correct updated value. So I do happen to have a Pluralsight course, so I'm going to shamelessly plug that here for routing and navigation. So I step through a couple of these patterns a little more and get more into the Angular router and some of the changes that were introduced in v16 and some of the they've actually been working on the router quite a bit, which was awesome when I found I was going to write this course. And then they're like, here's v16. I'm like, oh no, I mean, great, but oh no. So not what we wanted to hear.
The life of a teacher, right?
I know. And at the same time, I was writing this reactive patterns course or talk for ngconf. And then they released signals. I'm like, oh no. As promised, here is the GitHub link. So all the code examples are in this reactive patterns repo. And then this tiny URL is the link to my slide deck. If you'd like to look through it. I didn't actually put many links in it. Usually I just riddle them with links, but I didn't do that this time. So no links for you. You have to Google yourself. So yeah, the end.
Oh, that's wonderful. Thank you so much, Laura, for walking us through that. And I'm impressed that it seems, because it felt very cohesive. It did not feel like you were writing and then all of a sudden had a curveball. So
well, that's because the day of the talk, I was changing. So one thing we noticed, it was that the code didn't show up very well in dark mode. So I was switching out all of the code, and then I was like, why did I do it this? When you're really like combing over what you've done and being sort of like, oh no, I made a mistake. Yes. And so, yeah, there was a lot of last minute like changes, but then I also, the talk I gave at ngconf was more condensed. And so I feel like it's important for people to understand more about what a signal is, kind of how it works. And because I think I think it's like anytime some big change comes out, it is a big change, but it's not a big change. Like it is and it isn't. So, it's like, I feel like signals are going to be very useful sort of at the template layer. Like I don't think we're going to need to go and change everything to signals all the way up the chain. I think that we'll be able to use them judiciously. They are heavier than an observable. So it's not like you want to just be like, oh, I could use it. This could be a string property, but I'm going to make it a signal because why not? Like maybe just don't, unless there's some reason that value might change, you probably don't need a signal there. And so, yeah, I think it'll be really interesting to see what kind of patterns that we start to see. I know the community's been putting a lot of content out, and I just think as the library matures with signals deeper, we're going to see a lot more sort of big changes, but just kind of developer experience improvements in how we write our code. So
absolutely. Yeah. I wanted to highlight some people saying they loved the comic style presentation from Zen. There was also Marcus, brilliant as always, Laura, awesome talk, and Steve saying awesome presentation.
Nice.
And thank you for this.
I do want to reiterate something that you said earlier about how new features with 17 and signals are going to be drizzled out there after the fact, is to remember that signals are additive.
Yes.
It's nothing breaking from what's already out there. You don't have to go and change your code. There's just another tool in your toolbox that you can use to be able to improve your application going forward.
Exactly. And I feel like that was a lot of the anxiety early on, is people like, oh my God, do I have to now learn signals? I just finally got RxJS working for me. It's like, no.
You have to learn both.
Now you have to learn both. Why not both? It's kind of like standalone components. And like, yeah, you can write a full application that's just standalone components and it works great. I've done that. My Angular routing course is that way. However, if you live in the world of an existing application, the chances that the entire application that's a module-based application is going to get changed to standalone is that really your priority? Because it's not broken.
Right.
So, it's like, we will have to live in a world where we kind of understand all the things, but I think you can get by with this. Helps you get by on a sort of like a lighter, like a more surface understanding. If you can take an RxJS, if you can take an observable and turn it to a signal and then it works better for you, then that's fine. But just understanding that when it needs to become a signal and stuff. So
I loved it. I thought it was a wonderful, wonderful thing. And I'm actually going to check out your course because I'm really excited to say I did not know. Has it been there on like for a long time? How long?
I released it early July, like right before I went on vacation. So it was like the week I got really sick this spring too, so I was supposed to be working on it. So I basically had to do it in about a month, and it was my first course for Pluralsight, and it was a lot of learning curve of learning how to edit audio and how to record audio. I record audio all the time, but I've never like gone and sucked all the breath sounds out of it. You know? So, and then just figuring out the process of like, okay, so I wrote the code and now I have to like get this. I had to write a script. I'm not scripted. I'm not a script writer, right? But I had to do it.
You had, like, they require it? Like, you have to have
like I had to do it because I couldn't wing it and make sure I covered everything the way I wanted to cover it. Yeah. Plus, they do like to provide closed captioning for accessibility. And since I could give them, this is close to what I said. So I don't know if y'all have noticed, but like when we have like the closed captioning monitors up, particularly for people who speak quickly or with a heavy accent, we get some very interesting descriptions of how to write code. So,
yep. No, absolutely. If you can script those bits at least, absolutely.
Yeah, exactly.
Oh, well, thank you, Laura, so much. Do any of you, Laura, Justin, Mike, anybody have picks for today before we?
Oh gosh, what are we doing? Oh, well, Loki season 2 is coming out. So I have to plug that because my junior in high school needs you to watch it because they need it to last forever.
They need the puppet. Yes, I that.
So also, yeah, and on that front too, Our Flag Means Death is coming out as well, like second season in October. So there's kind of a lot of exciting television in October. So yeah, there's some great ones out there, and if you check them out and like them and watch them, then we get to watch more because they'll make more seasons. Yeah. So yeah, that's my frivolous pick. Yeah, my frivolous pick.
I love it. What about you, Mike? Anything? Any goodies now? Shorty?
I got nothing.
Nothing.
Yeah, I'll chain onto the content, right? So Ahsoka, obviously, big Star Wars fan, big Ahsoka fan. So that wrapped up. So if you haven't watched any, you can go binge it, whatever. But epic. Yeah. One Piece. So I've never watched One Piece, the animated series. So my wife and I came into it fresh. We really enjoyed the Netflix live action series.
That's good to know.
The acting and it was enjoyable. So that was super fun. Nice. But if you're a One Piece anime fan, don't at me. I'm sorry, I don't know anything. I'm just recommending it from a fresh viewer standpoint. We go into the whole Cowboy Bebop and how that played out, and that's a whole other deal. So, anyways, and then on the game front, Cyberpunk, I love that game. It just keeps getting better and better the more they patch it and fix it. But man, great storyline, all that stuff. So I'm super invested in that. And then Assassin's Creed came out yesterday, so
nice.
My daughter and I are on that, and so we're excited about that.
Well, I mean, and the good news is, like, at least in the northern hemisphere, it's starting to cool off, and so we'll want to be inside more, and so we have activities.
Yep. My pick is Blink-182's having a new album for the first time since I think like 2011 or something, some crazy amount of time, 13 something. So I'm super pumped. Always been a huge Blink fan. But they're like slowly releasing. So there's like, I think like 4 of the 14 or something songs out. I know. So go check out the 4. I don't know when the whole album drops. I think it's this month, but every time
I love the bands that are just like, I'm just going to take our time. So I love this band called The Wrens when I was in college, and they had this great like first release. Secaucus was a great album. Loved it. And then it took them like 20 years to go ahead and release another one. But Meadowlands was great. And so yeah, it's like there was always the running joke of, well, we just release every 20 years or whatever. So.
I could get behind that kind of release schedule.
Yeah. I mean, that was kind of how Star Wars went, right? It's like we got Star Wars when we were kids, and then it was like nothing, and then the floodgates open. So. Maybe we're just gonna get a whole bunch of Blink-182 like stuff from now on.
I know. Oh, well, thank you so much, Laura. It was a pleasure having you on. And thanks, Shorty and Mike, for being with us today. We're going to hear from our sponsors and sign off, but we'll see you all on the next one. Bye.
See ya.
Bye.
Angular Air is sponsored by Kendo UI for Angular. We have over 100 components built from the ground up in Angular or each framework and library that it's built for. So not only do we have Angular on the JavaScript side, but we have Kendo UI for React, jQuery, and Vue as well. And if you're on the .NET side of life, we have things for Blazor, Maui, WPF, and so much more. All of our libraries are themable, customizable, and of course come with killer professional support. So try it out for free today at kendoui.com.